Hello, everyone. Today, I am here to explain what is machine learning. So, in the previous section, you all have learned the basics and fundamentals of machine learning. Today, we are going to understand how machine learning works. And today's first session, which we are going to complete, that is completely based on regression part. So, let's understand and let's start from the basics of machine learning. Imagine teaching a computer the way we teach a kid. Similarly, if we show a kid lots of pictures like dogs and say, this is a dog, like you must have siblings, your younger siblings, whom you have taught that this is a dog, this is an apple, this is a banana, right? And over time, that kid learns to recognize what is apple, what is banana. Machine learning works in a similar way, in the same way. We give the computer data and it learns the patterns. And not just like this, it's not a magic at all that machine creates pattern and machine predicts. We make machine to think. We enable it to understand. Data makes it smart. And with the help of smart maths behind all the scenes, it predicts. It is as simple. So let's quickly understand and let's see deep dive and let's experience how machine learns. So I'm moving to the next slide and I'm going to ask a question. You are going to think in your mind and think like a child. If you are a kid, how you are going to think in that perspective. What is going to be the price of this car? Can you predict that? All right, if you have given your prediction, that's completely all right. Now, will the price of this car be keep on changing? What do you think about this bike? What is going to be the price of this bike? Will a kid be able to answer this particular segment? And if you are able to answer about the price of a car as well as the price of a bike, what about the candies? Absolutely. Kids, because they have seen, they have been eating, they will be able to predict the price of candies because they have seen it, they have bought it, right? Similarly, when you are teaching your machine, you are giving that data because data is the key. When you are giving the data that this car price is this much of amount, this particular car has these many features, this company is providing, this particular brand is providing, and calculating all the features, everything, the on-road price is going to be in front of you. Similarly is with the bike. And this is how a machine differentiates when you are going to provide the data, the information to a machine. Same is with candies, like we teach a kid. So let's quickly deep down to understand the factors that impact machine learning model. Let's understand the factors that impact machine learning model or prediction. When we talk about data, so the first thing is data. More number of data you are going to provide to your machine, the more accuracy you are going to get. Suppose you are giving only one type of car for your machine to understand that this is going to be the price of the car, then the machine is not going to get what feature it includes, what exactly different brands have, what is the difference. So you are going to provide n number of variants so that machine is going to learn on each and every feature and understand if this is an additional feature, the cost is also going to be higher. Right? So large amount of data is needed when you are training a machine. The more number of data you are going to provide for a machine to learn or to train upon, the better accuracy you are going to get. Next is correct and clean data. Make sure the data which you are providing your machine to train upon or to test upon, it should be bug free. There should be no null values or zero values in it or blurry image in it. It should be correct and clean. The next part is no randomness. When we talk about randomness, when you are talking about cars only, make sure that those are only cars, no other features or no other things are involved in it, right? Any randomness, anything which doesn't make sense or which impact the pattern. right? Suppose I'm taking this session and randomly I talk about something else apart from machine learning, then it is going to disrupt the flow of this session. That is called randomness. Next and the last part, which is very, very important, and we usually, when we are creating models, when we are creating any pattern or prediction, we usually you can say we just forget that particular factor, but you are going to keep in mind when you are creating and choosing a classification for your machine learning model. And that is no external factor involved which can impact the prediction apart from the data provided. Suppose I am giving a data to my machine to predict an income of a person whom the machine is not aware of. Suppose I am an HR, and as an HR, my responsibility is to hire a person for my company. And the job description I have. Now, the person who is coming in after interview or while taking interview, there is salary negotiation part in which after looking at the entire overview of the person or an individual, I am going to provide the salary expectation, right? Similarly, external factors are such as whether the person is the native of India or it is from overseas or somewhere from a different country. If it is not included in that data, then data is going to hamper because the currency is different in different countries, and that is going to impact the prediction because our prediction is going to give a false value to it, because that is also a factor which impacts the salary of a person. I hope you are getting that idea. Now let's understand the first part and how we are going to get started with it. And today we are going to create and prepare the data to run the analysis. So stay tuned with me. Let's understand the first part, which is linear regression and understanding of linear regression. Linear regression, one of the easiest ways for a machine to make predictions. Think of it like drawing a straight line through which you can predict and show different patterns. This line helps us guess the values of new points. Like you are drawing a line and you have x and y. What is the value? At every x, the value is going to be different, and it's a straight line. Either it is going to decline or it is going to incline. For example, when you are predicting the value or the price of a house, right? That is also based on size, right? It is directly proportional. Anything which is directly proportional, that is going to count it as in linear regression. Because if the size of the house is bigger, obviously the price of the house is going to be higher. For example, you can think if you are going to go ahead and buy 1 BHK house, the price is going to be lesser. But as a comparison, if you are going to buy a higher square feet area, which is 3 BHK, the price is going to be high, right? External factor is included in it, which is the location of that particular house. But if in the same society, you are buying and you are comparing the price of 1 BHK and 3 BHK, the price you are going to find that is different, and that is directly proportional, and it is going to come under linear regression. I hope you are understanding. If you are understanding, then stay tuned. We are going to move and I'm going to give you ample of examples so that you can understand what exactly is linear regression and how you are going to use it in your daily life. And today's session, we are going to create the data and we are going to work upon and visualize it on linear regression scale. So let's understand. Imagine asking a kid, can you tell me the price of a car? The car which we have seen. If the kid has never seen a car or learned about car prices, they can't answer. Same goes with the bike, same goes with the candies. Maybe if you have trained on enough data, linear regression learns from the data and find the best line to make the predictions. And this is the prediction which we are going to use. It finds the best fitting straight line or regression line through the data points. Let's see how it is going to create that with the help of some examples. Predicting house price that we have already done. Linear regression or larger homes, usually when you are creating a straight line, let me give you an example of that. If you can see this line, if you are starting for 1,000, then it is just 150, right? If you are moving ahead to 1,500, the price is also going to be high, which is 200. Similarly, you can see house size is 400 square feet, or like you can consider it vice versa. And at the bottom, you can see it is in dollars, right? So it's not like in 3,000 you are going to find, or you can consider it as a rent also, right? So if you want 350 square feet, then 3,000 rupees rent you are going to pay. So this is the visualization of a linear regression. This is how it predicts. Now, suppose we have not given data of 500, right? What about 500 square feet? What machine learning is going to do? It is going to extend this straight line little forward, and then it is going to predict its own price, right? This is how machine learning works. Even if it is not included in the data, it can predict that. This is how machine learning linear regression works. I hope now you got the clarity how machine learning works and how you are going to calculate the data by using simple technique. And with that, let's understand how this equation of a line works. In maths, we all have learned it. A straight line is written as y is equals to mx plus c, right? With x, that m is a constant. Y is the predicted price. M is the slope, which is how fast the price increases. And x is the input, the size of the house which you want. Wherever when you are going to start with the B point on the scale, the machine learns the best value for M and B to match the data. And thereafter, with the same straight line, when the prices are going to increase or the size is going to increase, you are going to get the price of it. This is how machine learning works in a very simple way. So let's quickly get started, and I hope you all get the idea how linear regression of machine learning works. It is the easiest and the simplest way to run the predictions. Now let's quickly move and create our own data set. Let me quickly share with you what data set we all are going to create and how you are going to work upon it. In today's session for linear regression, we are going to create a data set of our own. We are going to create the data set on Excel, in which you are going to create two categories. One is going to be the salary and the second is going to be number of years. So we are going to create a data set for an HR in which we are going to predict the salary of an individual who has n number of years experience, and with that year of experience, how much those individuals are getting salaries, right? Accordingly, we are going to train our machine, because more number of years of experience you have the salary packages accordingly. Less number of years of experience you will consider as a fresher, and less amount of salary you will be receiving. So it is also a part of linear regression, and that is what we are going to create. So quickly open your Excel sheet and let's quickly create our own data set. And with that data set, we are going to run our own prediction. I'm going to show you how you are going to set up your own, either if you are working on Virtual Studio Code or Google Colab or Jupyter Notebook. You can use any of those platforms to run your own analysis. So stay tuned. I'm going to right now create the data. So create data with me on Excel. All right, everyone. So I'm ready with my Excel sheet. I hope you all are ready with your own Excel sheet. Here I have created the first column which says years of experience, and I have kept salary as column number B. So today we are going to create our own data. Now, why we have started with this? Because when you are going to create your own data, as we are starting with our own prediction model, when you will be creating your own data, you are going to understand it in the best way, Rather taking a random data and then cleaning that data and understanding and visualizing it, this is the first step which we are going to understand using a very simple linear regression algorithm model. So let's quickly do that. In years of experience, you are going to mention years like 1.1, 1.2, including months and years. So that is completely up to you how you would like to create, or if you wanted to try out my style, you can do. Make sure when you are doing it that you are going to keep it bug free, so that you are going to create a superficial data in which there will be no null values as well as no discrete values or randomness. So I'm going to write 1, then 1.1, 1.5, 1.7, and 2, 2.2, 2.5, 2.8, 3, 3.1 or 3.3, then 3.5, 3.8, then 4, 4 point, or let's say 4.1, 4.2, 4.2, 4.4, and 4.9. We are going to take 5, 5.9, and then 6, because in age of 5 there is a gratuity time and very less people, they usually resign. 6.1, 6.6, 6.8, 7, 7.1, 7.5, 7.9, 8, 8.1, 8.5, 8.6, then 9, 9.3, 9.5, 9 point, or let's say 9.8. 8. I'm going to keep 10, 10.5, 11. So I'm going to keep the data of approximately 11 months, and accordingly, I'm going to define the salary. For an year-old experience, I'm going to give 7,000. For 1.1, 11,000, 15,000, 17,000, 20,000, 22,000, 25,000, 28,000, 30,000, 33,000, 35,000, 38,000, 40,000, 41,000, 42,000, 44,000. Keep it simple. You can write as per your own choice, because salary could be there are other factors also which actually discriminate the salaries. It could be when you are working in MNCs, so the salary is going to be different, right? When you are working as a teacher, and as well as when you are working as a software engineer in an MNC, but year of experience is 5, then the salary is going to be different. So it's completely up to you how you would like to take it. 61,000, 66,000, 68,000, 7,000, sorry, 70,000, 71,000, 75,000. Going to take 79,000, sorry, not here, over here, 79,000, 80,000, 81,000, 85,000, 86,000, 90,000, 93,000, 95,000, 98,000, 1 lakh, 1,05,000, 11. That's it. So I have now, you must have noticed that I have created it in an increasing order, like taking one, because it actually creates, and there are lesser risk, or you can say chances of errors. So I would request you all to create in that particular manner so that you are also not going to create any mistake in it, because this is the data, or this is the key in which you will be creating your own visualization. When you are going to draw a graph of it, it is going to create years of experience as your value X, and then salary is going to be Y. And there is a linear graph which is going to come across. In between, if you wanted to change some values, you can change and you can see the visualization, which we are going to do in the next class for sure. Till now, let's understand what we have learned in today's session. In today's session, we have understood the basics and fundamentals of machine learning, how machine learning actually creates the prediction, what is the role of data in creating the predictions and creating a predictive model. Then we have understood the factors which impact the prediction of a machine learning cycle. We have understood how each factor is involved, whether it is data cleaning, gathering the data, whether it is like lesser amount of data which we can take, or how it is good to take a good amount of data. How a randomness is going to ruin the data or your confusion metrics. Along with it, we have understood how to create a linear data for linear regression. So today's class was completely dedicated to linear regression. We have understood, you can say, the role of a line in predictive model of linear regression, and we have created our own data. So with that, I am Astha Sharma signing off from today's session. So stay tuned. In the next class, be ready with your Python work frame, and we are going to write our first Python code to create our own visual in the terms of prediction, and we are going to run our model. We are going to use Matplotlib as a library to visualize the data, and you can use any platform to run your Python code. You can use Visual Studio Code, Jupyter Notebook, or Google Colab, whatever you are comfortable with. But my request is be ready with your framework on which you would like to, or ideally, whatever you wanted to take, be ready with that. We are going to run our model in next session. So stay tuned with me. Thank you, everyone.